This is Jack Jackson back again, working some more on some measures of central tendency. In this video, we'll focus on some computation questions. So let's get right into it. Here is some data that we did earlier on some hypothetical data we had for candy sales. If you remember from our earlier videos, we were assuming that we had a class of students and they were doing a fundraiser where they were selling boxes of candy, and this is all of the students listed in alphabetical order by their first name, and these are the amounts of candy, number of boxes of candy. So some of this is repeating earlier work that you've done, but let's go ahead and do that. If you can work on an earlier plot if you still got it, or you can redo it again here for more practice. But start by creating a dot plot of the data. First of all, get a piece of graph paper out. Make you a scale, and then make a dot plot of the data. Compute the sample size, compute the total candy sales for the class, total number of boxes. Compute the quartiles, draw a box and whiskers plot below or above the dot plot using the same axis. And then I want you to compute the following measures of central tendency and illustrate them on the dot plot: the mean, median, mode, mid-range, and mid-quartile. So let's go ahead and see if you can figure out all of those things from this data set and illustrate those on the dot plot. This may take a few minutes, so you need to pause the video, work it out, and then come back and check your work. Press pause now. Okay, well hopefully you did this. And if you notice, this is the dot plot that we had earlier for this particular data set, which we have here. It goes from a minimum of 2 to maximum of 30. So you can see those are the ends of our whiskers for our box plot. And we computed the median already to be 14. With 44, you would take the average of the 22nd and 23rd one. And if you look, this was the 20, if you count from the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. There's the 22nd one. There's the 23rd one. Halfway between those where I've got the red line drawn is the median. And of course, we're just averaging 214, so that's 14 for the median. We've done this before. Similarly, we can construct the quartiles. Now let's see, we have 22 in the lower half, so it'll be between the 11th and the 12th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 11 and 12th one are both 12, so Q1 is 12. And then it would be between the 11 and 12th one from the top for Q3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 11 and 12th one are both 16s. So there's Q3, and that allows us to get our box plot. Notice that the median was a measure of relative standing that we've computed in the past, but it is also one of the most important measures of central tendency. So, in fact, generally speaking, the mean, median, and mode are all three actually used very often. And it's really a good idea actually to report all three for a data set rather than just picking one measure of central tendency. Sometimes there can be something about a data set that can be misleading if you only use one of those, but if you use all three, that can really help tell you where the center is, interpreted different ways. And of course, if you want, you can do the other two less frequently used measures. They are the mid-range. And how do we find the mid-range? Well, it's halfway between the two ends of 2 and 30. So you do that, just add the 2 and 30 and divide by 2, we get 16. So 16 is right here. Notice 16 is 14 from below 30, and 16 is 14 above 2. So it's the same distance from the minimum as it is from the maximum. The mid-quartile is kind of like that, but it uses the quartiles here. So we average the quartiles 12 and 16 and get 14. And so 14 is 2 above the first quartile, 2 above 12, and is 2 below the third quartile. It's 2 below 16. The mode is 15 because that's more people sow 15 than any other. So that's the most often occurring one. And notice that the mode is 15, not 1, 2, 3, 4, 5, 6, not 8, which is the frequency of that particular one. So it's the mode is the actual data value 15. Now to compute the mean, which is actually the hardest one to compute, we have to add up all of these data values. So we're adding up 2 plus 9 plus 9 plus 10 plus 10 plus 10 plus 11 plus 11 plus 11 plus 12, 12, 12, 12, 12, and so forth. And you add all those up, and you get 630. Okay, it might be easier to look at it this way and just type all these numbers in, say, a calculator, and add them up, or if you had to, you could certainly add them up by hand. And we add up all of those, and we get 630. Divide that by 44, which is the total number of kids, and it's a reduced fractions. That's 315 or 22. In other words, 14.3181818181818 with the 18 repeating forever. So on average, how much did the kids sell? Well, if you took the total 630 boxes and spread it out evenly so that every kid sold the same amount, each kid would be selling just over 14 boxes. The most commonly amount sold was 15. That was the mode. The median is 14 because half of the kids, at least in this rank list, sold below that, and half were ranked of sales above that. Mid-quartile was also 14. The mid-range was 16. So anyway, those are three different measures. They're all fairly close together, so we should see something roughly kind of symmetric and kind of mounded up in the middle, and that is in fact the case that we see here. All right, here's another data set, okay, with some data values given by dot plot, and see if you can compute these statistics. Some of these are measures of relative standing and size, well, one of size, a few of relative standing, and are measures of central tendency. Once again, see if you can compute these on your own. Come back, check your work. Press pause now. Okay, let's see what we can do. Well, first, I guess the easiest thing to do is see there's several that are pretty easy to do right off the bat. The one with the most often occurring is 4, so there's the mode. The minimum is down here, which is 1. The maximum is up here, which is 13. Okay, and let's just go ahead and look at this. So let's see, we could count the dots, 1, 2, 3, 4, 5, 6, 7, 8, and so forth, and I get 20 of them. The median, then, if there's 20 dots, let's see, 20 plus 1 is 21, divided by 2 is 11.5, or 10.5. So between the 10th and 11th one will be the median. So let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10 and the 11th one are both 5. So the median is 5. Averaging those two is 5. Then you have 10 data values below that. So of the lower 10, you put those in order and you go halfway in the middle there. So that would be between the 5th and 6th one. So let's do 1, 2, 3, 4, 5, and 6. 5 and 6 are both 4s. So 4 is the Q1. We go, again, we do between the 5th and 6th one from the top will be the Q3. 1, 2, 3, 4, 5. The 5th and 6th ones are both 7s, so 7 is Q3. And like we've already said, the minimum is 1 and 13. So the mid-range then is just take 1 plus 13 is 14, divided by 2 is 7. The mode, we already said, the most often occurring one there is 4. And the mid-quartile, then we can easily compute from Q1 and Q3, is you take 4 plus 7 is 11, and divide by 2 is 5.5 for the mid-quartile. And then to get the mean, which is the most often used measure, is probably the hardest one to actually compute. You have to actually add up all the numbers. 1 plus 3 plus 3 plus 4 plus 4 plus 4 plus 4 plus 4, and so forth, and add all those up, and then divide by 20, and that turns out to be 5.7. Okay, so here it is, the table with the details given for the computation. The sample size is count the number of data values, which is 20. The minimum is the lowest data value, 1. The median is the middle of the ranked list, so it's going to be the average of the 10th and 11th one in that list, which are both 5, so that's 5. The median of the lower half is the Q1, which will turn out to be the average of there's 10 in the lower half, so it'll be the average between the 5th and 6th one, which are both 4s, so that's 4. The median of the upper half then is Q3, which is the average of the 5th and 6th from the top, which is both 7, so that's 7. The maximum is the highest data value, which is 13. We can use those to compute the mid-range and mid-quartile. The mid-range then is just the average, the minimum and maximum, so 1 plus 13 divided by 2 is 7. The mid-quartile is Q1 plus Q3 divided by 2, which is 5.5. The most frequent one you can see is the one with the most dots, which is 4. And then to find the mean, you add up all the data values and divide by n. So when you add up all the data values, that's 1 plus 3 plus 3 plus 5 4s plus 3 5s plus 3 6s and so forth. You get 114. Divide that by 20. You get the mean of 5.7. Now we can illustrate those on the dot plot as well. Let's see here. So this is the same data value here. The mean is 5.7 where this triangle is. That's the balance point. You want to think of that as a center of mass. So that would be where you put the balance. And then our box and whiskers plot here illustrates the quartiles. The minimum is 1. The Q1 is 4. Median is 5. The Q3 is 7. The max is 13. And of course the box is our middle half of the data. That also illustrates the central tendency, the median right there. And you can kind of see I've kind of got a line drawn where the median is, where Q1 and Q3 are. The mid-range is 7. It's right here, which is halfway between the minimum and the maximum. But notice about 3/4 of the data is below it, only about 1/4 above it. So it's not the same amount of data in each part, but it is the same distance. Whereas the median, there's 10 data. If you count the one above this as the top half and the 2 below it as the bottom half, there are 10 above and 10 below. So there's the same amount of data below, but you see it's closer to the minimum than it is to the maximum. The mode, again, is pretty easy to see. It's the one that's most often occurring. All right, here's one where I give you some heights and some frequencies and have you compute some measures of central tendency and relative standing for this. Again, the same ones here, and see if you can go ahead and compute all of these things here. Let's start by doing the sample size, the minimum, maximum, and the mode. Let's get those three things first. Press pause now. Well, the minimum is the lowest one, which is clearly 64. The highest is clearly the biggest one, the maximum, which is 70. The one that's most frequent is whichever one of the frequencies is biggest, 5. It's not the frequency, though. It's the x value, which is our height in this case, which is 66. And if we add all the frequencies up, we get the sample size of 18. Now, with just the minimum and maximum, we should be able to get the mid-quartile, or let's say the mid-range, pretty easily. And we could go ahead and compute the quartiles as well. All right, now let's think about this. If they've got, well, first of all, let's just do the mid-range. The mid-range is the minimum plus the maximum divided by 2. So that's 64 plus 70 divided by 2 is 67. Now, to do the mid-quartile, we first have to find the quartiles. Okay, so to do that, we need to start by finding the median. So let's find the quartiles here. So we already have the minimum maximum. To find the median, we need to take this and find the one that's in the middle in a ranked list. Well, they're already in order, but I have frequencies here. So if there's 18 data values, 18 plus 1 is 19, divided by 2 is 9.5. So we'll average the 9th and the 10th one from the bottom. So if we count up, that's 1, 2, 3, 4, 5, and 5 more is 10. So the 9th and 10th one are both 66s. So then that makes the median 66. Now, of the 18, we'll count 9 as being in the bottom half. So let's see, we'll count a 2, those two 64s, the 3 65s, that's 5, and then 4 of the 66s as being in the lower half. Okay, so of those 9, the 5th one from the bottom is the Q1. So if you notice, the 5th one from the bottom will be one of these 65s. So 65 is the Q1. Similarly, the 5th one from the top, which is one of these 68s, will be the Q3. Well, now that we have Q1 and Q3, we can average those, 65 plus 68 divide by 2 to find the mid-quartile. That's 66.5. Now, save the most commonly used one, but hardest to compute, the mean, for last. Okay, see if you can go ahead and find the mean for this data set. Press pause now if you haven't done this already. Okay, so what do we have to do? We have to add these up. Well, what we're doing is we're adding a 64 and another 64. And then we're adding 3 65s, and we got to add 5 66s, 2 67s, 4 68s, a 69, and a 70, and divide all of it by the total of 18, which is it's the sample size, the number of data values. Well, we could do it that way, but we could also notice that a short way for repeatedly adding the same thing over and over again, a shorthand notation for that is what we call multiplication. So 64, we could think of that as 2 times 64 or 64 times 2. 3 65s we could write as 65 times 3. 5 66s is 66 times 5, and so forth. So we could take each of these things and multiply them together. 64 times 2, 65 times 3, 66 times 5, 67 times 2, and so forth, and add those numbers up. So, okay. And then divide that by 18. That would be a little bit shorter way of doing it, perhaps. But let me show you one other way of doing this. Okay. I could take the 18, really a 1/18th, and distribute it and put it in with the frequency. So now I have 64 times 2/18ths, plus 65 times 3/18ths, plus 66 times 5/18ths, and so forth. Now, this doesn't necessarily make the computation any easier. In fact, I would just stop back here at the line before if I were computing this. In fact, if I were computing this, I would do parentheses 64 times 2 plus 65 times 3 plus 66 times 5, and so forth, just like it is here on this line. Close parentheses and say divide by 18. But I do want to show you that what we're doing is if we have a height and frequency or data value and frequency, we can multiply the data values times the frequency, add those products up, and divide by sample size. But if you notice these numbers in the parentheses here, the 2/18ths, 3/18ths, 5/18ths, those are actually relative frequencies. So if this was a relative frequency table, you can multiply the data values times the relative frequencies and just add them up. The dividing by 18 would be already included. Well, either way you do that, you get 1,198 over 18, or 66.5 with the 5 repeated. So again, looking at the table here, what we could have done is just multiply this 64 times 2 to get 128, 65 times 3 to get 195, and so forth. Add those up to get the 1,198, divide by 18, and get that. So the x bar, by definition, is the sum of the x's divided by n, but if we have a frequency table, if you take each x times its frequency and add those up for all your x's, divide by n, that gets it. Or if we just take the x times the relative frequency and add those up, that gets it as well. So the relative frequencies are taking these frequencies and divide by 18. the frequencies here, these frequencies, divide by 18, and we get these. Of course, those sum to 1. And if we multiply the 64 by 2 18ths, we get 128 18ths. And 65 times 3 18ths is 195 18ths, and so forth. And if we just add up these relative frequencies, then that gets us the mean. Any way, either of those ways you do it, you get 66.5 repeated. Now, how can we estimate the mean from this grouped frequency table? Well, we can't find the mean. We don't have enough data because we don't know whether these two data between 40 and 44, they could be both 40s, they could be a 40 and a 41, or 42 and a 44, or two 44s, and so forth. We don't really know. So there's really not enough information here to find the mean, but we could estimate it. So what's our best guess? Well, our best guess would be to choose the midpoint here, halfway in the middle here, to be our guess, and then we could use that as representing. So in other words, we could assume that these two people are, at least their average of the two is 42. It's not necessarily an accurate assumption, but it's sort of our best guess. Using that method, see if you can figure out the mean or approximate the mean in this situation. Well, here's what we do. We can do halfway in between here, which is 42. Halfway in here is 47, and so forth. And we multiply those by the relative frequencies here, which is 2 43rds, 7 43rds. These are decimal versions of those fractions. And multiply those out, we get decimal values here, and there's a decimal approximation for that. Now, we're probably going to round that off because we certainly don't know the mean at all. Really, this is only an estimate. We certainly don't know it to this many decimal places. So we could do this. So in fact, this data is actual data. This is data from the ages of U.S. presidents at initial inauguration, a data set that we've been going back to many times in these videos. And this is if we were grouping them together. And we came up with an average of 54.67 rounded to 2 decimal places. So about 55. Okay? And this approximation is not always super good, but actually turns out to be really good in this particular case, because if we take their actual ages at initial inauguration, its actual mean is 54.67 to 2 decimal places. So it's actually accurate to 2 decimal places in this way. That's kind of unusual for it to be that good. Notice that we cannot find the mode from this data, but we can find what we call the modal group. So if it's grouped like this, the group with the highest frequency is the lower 50s, the 50 to 54 age range. So that gives you a few different ways of looking at some computations, little practice problems that we checked and worked through, and working with frequency tables, dot plots, and maybe relative frequency tables to come up with some measures of central tendency, and we reviewed some measures of relative standing as well. So time to work some more exercises on the homework and come back for the next video.